significant value to the customers. Sorry, something happened. Okay, I just have to click on it itself. So my team provides optimized, as I mentioned, AI software, which is playing a very significant role in providing these values to the customers, developers, data scientists, and as you can see here, the different personas through all stages of the pipeline. And I will touch upon what stages they are, whether it's data pre-processing, creating a model, deployment. So we basically encounter different customers in different sectors, and we create optimized software for each stage of the pipeline. And we have hundreds of use cases. So I'm going to touch upon a couple of those. And here, as you can see, agriculture, where can it help increase efficiency, even diagnose diseases, to say telecom, helping drive higher network operation efficiency, to healthcare, smartphone, autonomous driving, you name it, right? Everything we do in our daily lives is impacted by AI. And again, I will give you some examples, and we can discuss more if you are interested in one specific field. So if we can please move to the next slide. Okay, so my focus, as you know, my team is, I have a global team that works on AI software. We produce software, and I actually have a slide, so I will wait till then. But before I talk about AI software accelerator, it's very important to talk about hardware acceleration, right? What kind of hardware, what's happening? So the increasing diversity of AI workload, and there is, again, I have another slide, so I will wait till I mention what kind of different types of workloads we have. But the fact is that increasing diversity of AI workload that demands a variety of AI optimized hardware architectures. And you can classify that into three main categories. One is the AI accelerated CPU. The second is AI accelerated GPU. And then we have dedicated hardware AI accelerators. So we see multiple examples of all three of these hardware categories in the market today. For example, as it shows here, Intel Xeon CPU, which has DL boost. These are AI specific hardware boosts, hardware accelerators. We have Apple CPU with Neural Engine. We have NVIDIA GPU with Tensor Core. We have Google TPUs, Habana, Gaudi, and many others that are in development by a combination of your traditional hardware companies, your cloud service providers, as mentioned here, like Google TPU. And there are many AI startups who are also building the hardware. So this is another very important area. And in this slide, you can see all three of these examples of the three types of accelerators at Intel. So let's move on to the next slide, please, where we talk about software AI accelerator, which is my focus area. So what does a software accelerator mean? A software AI accelerator is a term used to refer to AI performance improvement that can be achieved through software optimizations for the same hardware. So software accelerator can actually make platforms over 10 to 100x faster across a variety of applications, models, use cases. And we have proven that over and over again. Like we have customers and we will say, okay, here's an optimized software, run it on CPU with this optimization. As I mentioned, we have seen orders of magnitude, 100x improvement or more in many cases. So while AI hardware continues to make tremendous strides, the growth rate of AI model complexity is far outstripping the hardware advancements. So I'll give you an example. For about 3 years ago, a natural language AI model, Elmo was a very popular one, had just 94 million parameters. That's huge, but I'm saying just because the largest model these days, a BERT model, etc., have reached over 1 trillion parameters. And so the exponential growth of AI has meant that even a 1000x increase in computing performance can easily be consumed by these ever growing, ever more complex problems. And this is only possible to solve these possibles through the orders of magnitude, as I mentioned earlier, performance enhancements driven by software AI accelerator. And so that has been our focus area for the past few years. We've made performance, we've made great strides, and software performance has increased tremendously. But that's not the only thing. Besides performance, we also need to focus on simplicity. And as I tell my team that we have great performance, but what good is that performance if it's not adopted by the ecosystem, adopted by data scientists or developers? So we are also focusing on out-of-box performance. We're also focusing on open, how we interact with open source, how it fits in there, compatibility with the rest of the AI software ecosystem. So we are focusing on all of that, but my point for this slide and most of my presentation is that software AI acceleration is a must, and you need that in order to keep up with the ever-growing AI needs. So next slide, please. So this was published by KD Nugget, and it's a busy slide, but it's a map of key AI tools and libraries in data preprocessing, in classical machine learning, and on the right side, deep learning. And this is showing as positioned by their popularity. So the XY axis here are representing some metrics to measure how popular an open source project is amongst the software developers that were interviewed and polled. So the key point I'm making is if you look at these light blue ellipses and circles, so those are where we are focusing on, meaning we internally look closely at the landscape, and we are working tirelessly with the community and the owners of these open source software to make sure that we improve the performance on our hardware, on our CPU, and provide performance benefits to our developers. So for example, my team has been working with Google for the past many years to make sure that TensorFlow performance is the best possible in CPU, and we upstream all the optimizations that we do. And the last release 2.9, all those optimizations became default. So if a developer just goes and downloads the TensorFlow, runs on CPU, they're going to get all the 1DNN and all the optimizations we have made. So this is the point again, is that if you look at Pandas or Apache Spark, those are the go-to libraries in data preparation. Or if you look at XGBoost, these are machine learning boosting, gradient boosting libraries, scikit-learn machine learning framework, and TensorFlow, PyTorch, all of those things that are there. These are the most popular frameworks and libraries in AI world. And we all have to work together with that. And we are, not only we have our own tools, but we also optimize these. And that is in order to provide developers their favorite tools and performance multifold so that we can improve the TCO for our customers. Next slide, please. So this is the software stack. If you look at it, again, somewhat busy. We try to simplify it, but there's so much going on that it's kind of hard to really simplify it, but let me try. So there are 3 swim lanes here. And what I'm trying to show here is that how our Intel AI software is fitting with respect to each other in the data, in the AI pipeline. So the first is engineering data preprocessing, then creating a model, deploying the model. That is your typical AI lifecycle pipeline. And then let's start from the stack at the bottom level. And again, this is a combination of open source library plus some of the ones that we have created. A lot of it is already open source. So let's start from the stack at the bottom level. That is all the low-level performance libraries like compilers, kernels, that are very close to the hardware, and they provide great performance enhancement. So we have our one API layer as is showing here. That is a unifying layer across all hardware. And so it provides highly tuned software, but it's the same layer, same software that will work across your CPU, GPU, HANA accelerator. That is the whole point. So that is the unifying layer. Then if you move up, go to the second layer. This is where most of the data engineers, data scientists, they operate at this level. This is the framework layer. And this is where it represents most popular frameworks. And say, I mentioned that earlier in data prep analytics, you have pandas and sparks, numpy. Then you have TensorFlow, PyTorch, scikit-learn, XGBoost. These are the most popular deep learning and machine learning frameworks. So these are part of our AI software where we have optimized it using MonDNN and other libraries. The top is typically where your AI toolkit and MLOps platform exist. So we have SaaS tools like SIGOPT, and these are going to help developers with hyperparameter tuning optimization. That is a difficult task. So we help with that, even choosing a model, what would be most suitable. Then we have another thing that my team created, Intel Neural Compressor, which is mostly for post-training optimizations. And that, again, tremendous adoption of that tool because it gives a lot of great performance by quantization, low precision optimizations. And that also helps without loss of accuracy. BigDL is a tool that we have that helps customers run on distributed model. OpenVINO toolkit that accelerates inference. And basically the point of this is that there is so much of software that is needed depending on where you are in the life cycle, depending on who you are, different persona. And we want to make sure we cover all different aspects of AI life cycle. If we can move to the next slide, please. So this I kind of threw in here because this is I'm very passionate about this thing, ethical AI, responsible AI. And I wanted to add this here because not only that I'm passionate about, but this is also a very, very important and hot area. And also my team is working on that. We are doing some work here. So again, so AI is everywhere, making phenomenal progress, but incomplete, underrepresented, mislabeled data, or algorithmic biases can make life-changing decisions, which have found to be, and I've put in some examples here. There are many, many examples, right? So the first one, the recidivism, ProPublica had published this a couple of years ago, and where essentially what we're saying is that risk assessment used to inform decisions about who can be set free at any stage of a criminal justice system, from assigning bond amounts to even more fundamental decisions about a defendant's freedom. These AI results were given to the judges during criminal sentencing, and they would use that. And it was found to be extremely biased against certain races. And when ProPublica published that, it had to be shut down. And a lot of talk has been done. And last year, the Squirrel Award, which is equivalent of Nobel Prize in computer science, was given to Cynthia Rodin from Duke University because of the work she's doing in responsible AI. So it's a really, really an important area. And other examples, right? The one below that, the hiring tool, it was shut down, and pretty sure most of you know about it. It was shut down because it was biased against women. And why was it biased against women? Because the data that was used to train these models was showing that white men were the best the candidates, and that's what the historical data was. And so that's what it would say is a good candidate. The stop sign was one of my favorites. It was published by UC Berkeley study, where to us, to human eye, it's like a graffiti on a stop sign. But if you put these stickers, autonomous driving, a car, a vision model would not even recognize the stop sign. So there's so many things that can go wrong with that, right? On the top right is the Obermeyer study, which found evidence. I actually found this case very interesting and studied this paper quite a bit, was that we found evidence of racial bias in this widely used algorithm where Black patients were assigned the same level of risk by the algorithm. These Black patients were much sicker than the white patient, but they said this is the same level. And again, why was that? Because the feature that the algorithm was looking at was how much dollar amount was spent. And if you look at the dollars amount that was spent on these patients, it was more for some, not looking at how sick the patients were. So there are numerous examples, and this while I'm just getting your attention to how many, what are the limitations of bias. I don't want to give any talk on AI without mentioning how important the bias and ethical problems in AI is. And the next slide, it's a POC, it's a work in progress. Yeah, there it is. But I want to show this. This is some of the work that my team and I are doing in responsible AI, explainable AI, right? So, and it's not just us, obviously, there's like all companies are rallying behind this. And as mentioned in the previous slide, some decisions are made by, say, these deep learning models, and that is like a black box. If a loan is denied, what was the reason? And that's where this explainable AI comes in, and something we are working on. So if you look at the slide, and I just took it from one of the internal presentations. So if you look at the top layer, I already talked about this, right? The software that we have, both Intel and the popular deep learning, machine learning frameworks, etc. So that I'm showing, this is your top layer. This is the AI software. The next layer is showing you the workflow, the data pre-processing, training, deployment, quantization. And the last layer, what I'm showing here is that ethics must be integrated into, number one, earliest stages of this slide. Sorry, something happened. I cannot see.
No, I think there is a question on the window. No worries, Sima, you continue. We will take the questions at the very end. Yeah.
All right. Okay. All right. So it just popped up and sort of. Okay. Sure. So yeah, if we can hold on the question so that I make sure that I cover this and then Meena also covers her part. So what was I saying? Yeah, the last layer. So I'm making sure that it is integrated to the earlier stages of AI research, and it continues to be prioritized to every stage here. And so Meena, for example, right, if she's publishing a model, we have to go through this whole checklist. For example, data sheets for data set. So where did the data come from? How comprehensive it is? Does it represent all? How is it going to be updated? Similarly, we have model cards. So that is to encourage transparent model reporting that provides benchmark evaluation with respect to culture, demographic, that are relevant to the intended application domains. So model cards. So what I'm trying to do is automate these things, right? That it is generated. And the other part that we are doing is that shows you this explainer, right? So we are building our explainer, and we are not starting from scratch. There are lots and lots of wonderful tools out there. One particular tool is SHAP. It was developed by University of Washington, and that has Shapley value, and that basically in a model it shows what is the most prominent, what is the biggest feature that the decision is being made on, and then you can manipulate that and then try. So there's a lot of work that's happening. We are far from done, but this is an area which is very, very important, and I just wanted to give you a glimpse of that. So next slide, please. I hope I'm doing okay on time. I will speed up a little bit so that I give Meena some time. So Project Apollo. By the way, we have lots and lots of engagements besides the customers. We have many programs ourselves. We have a huge collaboration with Hugging Face, which is the de facto for language models. We have our own AI builder program, and many AI disruptor programs. That's how we interact with the ISVs, the CSPs, with all of those. So this is just something which is very new, so I decided to put in here. We just made the announcement, and this is our collaboration with Accenture. And we are creating these reference tools, developing a hub of AI reference kits. And over 30 AI reference kits, and what it will have is trained machine learning, deep learning models, and this will be released to the open source community. Each of these kits will include model code, training data, instructions for machine learning pipeline, libraries, etc. And the idea is that it's going to reach millions of developers, and these developers are your general developer, your data scientists, AI developers, edge IoT developers. And this contains the leading industry software like Python, Pandas, XGBoost, etc., as well as our own ink tool that I mentioned, the container that my team is producing, etc. So this was something new, and I wanted to share that there will be lots and lots of reference kits that will be coming on board. Moving on quickly. So this is again kind of personal, but I've seen this to be interesting to people. In a lot of my talks, I do that. So I like to paint. And this is combining, and I kind of did this early on when I was getting into AI. So this is kind of combining a passion for engineering and art. And for one of my recent projects, it's not really recent, but it keeps improving. So I used an AI optimization technique called neural style transfer, which is composing image and style of another image. So it takes two images, a content image, for example, one of my paintings, or embroidery, or whatever else I do, and a style reference image. So in this, I'm not showing, but I tried it with Van Gogh and Monet, etc. And then something completely different. Actually, I do have one for Van Gogh also. Completely different, like an image of Intel chip. And then you blend them together. So the output image, as you can see, will look like content image, but painted in the style of reference image. And all this can be done in like, less than 100 lines of code, and generating this restyle painting is instantaneous. Again, thanks to the software optimization. So this is just a small use case, but AI and art, we can have a whole talk on that. In fact, I did in I think Ganhai invited me to talk about this, plus, like music and how much difference AI is doing in daily lives. I think I have a couple more slides. I will do it fast. AI and model. This is a MasterCard. This is an example of one of our customers using our tool, Big DL tool. It used to be called Analytics Zoo before. And what this is showing is a great example of building a universal recommender AI system. So this is the collaboration with MasterCard, and MasterCard has a very large history of credit card transaction, which is, as it shows here, greater than 1 billion in this case. So there was a user item propensity model that was built to generate market insights to deliver very personalized recommendation of relevant products. So again, MasterCard has its own existing big data, right? And they have their own infrastructure. And so what we did was to meet their enterprise requirement, meaning using their own infrastructure, existing infrastructure. And that, number one, avoided, of course, production savings, but avoid many challenges that can come from deploying solutions with incompatible software and hardware. And the application directly processed all the massive amount of data. So as you can imagine, that these are very private, and MasterCard wouldn't want their data to be used elsewhere. So in this case, we are using all of that, using their own infrastructure without moving the data, using NCF wide deep model in a distributed environment without exporting or moving data to another cluster. So this was it was a very successful model, and I wanted to touch upon that. And the last slide that I have, another one of you can say my favorite use cases. And actually, let me just start from the right side and explain what federated learning is. So federated learning is a distributed machine learning approach. And this enables organizations to basically collaborate on these machine learning projects without sharing sensitive data, such as your patient records, financial data, any IP. So the basic premise behind federated learning is that model actually moves to meet the data rather than typical data moving to meet the model. And again, this is minimizing the movement of data. So on the hardware side, I want to quickly mention that Intel has this software guard extension, XGX. That is a very important security feature available in the CPUs. And this SGX, that's what it's called, it helps protect data in use via this very unique application isolation technology we have. And lastly, applying this example, UPenn and Intel Lab, we worked on this federated medical imaging training, and actually the study demonstrated that using federated learning method, it can train this deep learning model, UNet was the model used, with 99% of the accuracy of the same model trained in your traditional non-private centralized way. So there's not much loss of accuracy. And it's also showing that if you use all this training data, you have 17% better results when compared to a model trained only on the hospital's own local data, and 2.6% better than on a local validation set. So I'm going to hand it over to Meena. I hope I didn't take too much time and give you 15 minutes.
No, I think it's fine. I think I have enough time. Thank you, Huma. Hey, thanks everyone. Hope you can hear me okay. Can you go to the next slide? Thank you. So let's just jump in and talk about one other use case, and then I will jump into the hardware challenges and the end-to-end AI system and optimizations that I work on. So Huma touched upon a lot of the software challenges, right? So in addition, there's another workload here, our customer use case, with the advent of 5G technology and a growth of large numbers of devices and very fast data rates. The COSPs, or the communication service providers, in this particular case, this is the largest mobile operator in South Korea, SK Telecom, and they have this massive amount of telemetry data that they collect on every call and every kind of event that happens on their cell towers. And this is collected every 5 minutes, and this is a time series data. And how do you manage and how do you sort of glean and get analytics out of it? Of course, AI comes to the rescue. In this particular case, Huma already mentioned about Big Deal. What Big Deal does is it brings the big data and the deep learning together. So what we do here is, in this particular workload, it also, by the way, uses the SGX technology she talked about, the software guard extensions to create these secure enclaves or isolate these applications. And essentially this large data set is then pulled into a Flash base database into Spark, converted into a Spark data frame, and then apply the deep learning model for the time series in place working on it. So this is something that the customers really appreciated the solution, because they didn't want to invest in multiple different types of hardware. They wanted to have general purpose CPUs, which they were anyway doing big data on, and they wanted to bring deep learning together to there, right? So as a result, performance per dollar, performance per watt, everything improved dramatically. So let me switch gears, next slide please, and look at two areas that I'm going to talk about. One is the AI hardware challenges. Huma already touched upon some of that, and also want to talk about efficient, how are we going to build efficient end-to-end AI solutions. So this is a really popular chart. If you haven't seen it before, what it is basically showing you is all the models, AI models, are growing in capability, in size, and they're reaching human level accuracies. What does that really mean? The amount of compute needed is also steadily increasing. It doesn't come for free, right? The models are getting more complex. They're getting more and more parameters. Like, a few years ago, they were in the order of millions. Now they're in trillions. It's just complexity, number of layers, the whole model sizes are growing. What does that really mean? How does that challenge? Basically, you can see that the blue line is like 15x every 2 years, right? That is the rate at which flops are the floating point operations per second, the compute needed for these models are growing 15x every 2 years. Now you can see the red line, which is the much steeper slope of 750x every 2 years. So these are the transformer models, which are the very popular kind of the latest and greatest technology with multi-headed attention. And this is a much more nuanced understanding of languages. Imagine translating 500 languages, source languages into 500 targets, or sentiment analysis, text classification, many different applications for NLP. And you can clearly see that the exponential trend of these AI accelerators just need more and more compute. And as a result, what happens is a lot of the memory hierarchy or the die space is given more for compute and less for memory hierarchy. And as a result, now you're creating this memory wall problem. So it's called the famous AI memory wall, because the models are getting larger, bigger in compute, but how do you build systems that can run these models, which are just growing like crazy? You may have heard of this OpenAI GPT-3 model, the Turing model from Microsoft. These are all in the order of trillions of parameters, right? This is growing pretty large. So, and the gray line here is showing the Moore's law, which is growing 2x every year. So every 2 years. So let's next slide, please. So we have to really look at intelligent ways of building these models. And I can tell you here, there is the AI and memory wall that I talked about. The green line is showing accelerators, how the memory trends are growing. And they're at 80 gigabytes. And you can see the red line, which is the sizes of these models. And the transformer models are growing 240x every 2 years. So clearly, you cannot just do it on one or a bunch of accelerators. You need to have a heterogeneous solution. And you can even see the recommendation models are going in the order of terabytes of parameters. So these are really pushing the envelope, and this is a problem that needs to be solved. And there are many areas of research, not just building new hardware, but new techniques, which we will talk about, like using small data, using better models. There's something very hot area called self-supervised learning, because human beings, apparently, we don't really need a lot of data. As a child knows an object is put somewhere. If you don't put it in a proper place, it will fall down. There's a concept of gravity. You start building mental models of physics. So there are new techniques, new areas of AI that are coming up. Okay, so let's go to the next file, please. I think Huma talked about this already. So here, there is a concept called AI chasm, which is only 17 or 15% of the models that are actually developed in pilot mode actually go into production, because there is a whole lot of data engineering, data wrangling, feature engineering, and then model development. And it's not like you create the model and it's done, right? There's a ton of prototyping, and it's an iterative process. And then you finally train the model, and then you deploy. And then to add to the other problem, which is the fairness, and there's something called model drift, which model keeps changing, or the data drift, and the model conceptual soundness of the model starts degrading. So you need to go through this process again, or you get new data, right? So this whole cycle kind of repeats. So not only do you need to be very cognizant of this in the hardware, but also in the software that we build, right? Okay, so let me give you an example of what kinds of pipelines my team and I work on. This is just one example. This is a document level sentiment analysis. So typically, you're giving either reviews, or whether it is about a stock, or even movie reviews, or a restaurant reviews. There's an AI application behind it going through these documents. And so here there are sort of two pipelines. So one pipeline is ingesting this data and then tokenizing the data set. And then the top pipeline, it's tokenizing, creating tokens out of this text data, and then loading a pre-trained model. In this case, I'm taking a BERT large uncased model. And then we do something called fine tuning, because training a model from scratch can take days. Not only that, can take an enormous amounts of energy and compute power, right? To the point where you can fly to intercontinental flights with the amount of energy you will be spending. So a lot of people do this concept called fine tuning or transfer learning, where you take a pre-trained model and then you change a few layers for your specific or related task, but different task or a related task. In this case, it's a masked language model we are applying for a sentiment analysis. And then we fine tune it on that particular data set and then use it for the pipeline below, which is an inference pipeline. In this case, the inference pipeline is essentially the same concept, except it's on the data that the inference data, right? You're going to tokenize, load the data, load the fine-tuned model, and then go through the inference process, and then publish a green or a red, positive sentiment or negative sentiment on the data. In this particular case, we were using some movie, these are all public data sets, right? Movie review, IMDb, and Stanford tree data sets. But so what I'm trying to say is this is a very simple pipeline, but imagine this at scale in production, in an enterprise, for example, a large franchise with many branches. Imagine the complexity to put this into deployment, right? All those challenges we need to tackle. And there's a term called ML ops coined for this. They are like DevOps, like DevOps we have for general purpose software. This is like ML ops for machine learning software. In addition to the DevOps, you also need to be cognizant and account for the bias and model drift and data drift and conceptual soundness. Next file. Okay, thank you. So this will be my last file. So what I wanted to say was, just wanted to give you a sort of a taste for the kinds of things that happen when you are training. It's called Deep Speed Zero Infinity, just to show you the complexity that is involved, how to map these large language models or large recommendation models or graph neural networks onto a large cluster. It could be in the order of hundreds of GPUs and hundreds of CPUs. So you definitely need to have a heterogeneous kind of hardware setup, because you need large memory capacity, you need the high compute intensity, or and you need also very good storage and memory, as well as very high interconnect bandwidth, right? So this is your classic sort of really beefed up training cluster. But even here, there are lots of techniques that you need to apply. For instance, things like so what this table here is showing you is there are different kinds of partitioning or parallelism that you're taking advantage of. Data parallelism, pipeline parallelism, model parallelism. So what do all these things mean? Data parallelism is you try to work on multiple chunks of data, multiple batches of data. Instead of doing one image at a time, you combine, have a bunch of images, and then you go through the training process. And why? Because it gets you better efficiency out of your hardware, and you can also go through the steps faster. Again, you cannot go to increase your batches huge, because then there are other issues of convergence and other things. The other thing is you also want to make sure that your models themselves get partitioned and get allocated to different parts, so that when you are fetching one piece of data and working on one layer, the other layer can be in parallel overlap and do some communication with other nodes. So you want to overlap and you want to increase your pipeline parallelism. So you want to pipeline them so that there are no dependencies or bubbles in your pipeline. At the same time, you want to increase the compute efficiency. So it's a classic problem of any large-scale distributed system. You want to make sure that everybody is busy working productively and getting to the solution really fast. But at the same time, you want to make sure that in this particular case, in the AI case, you have things like convergence. You have to make sure that all your loss is minimized. But as you start having more and more nodes, you need to communicate between each other and keep track of your gradients and your loss and things like that. So you have to keep that in mind as well. And this is a really nice work from Microsoft. And a lot of companies are doing this. And this is an area that my team also works on. So our goal is to find out what are the right optimization points, performance, power, TCO. It's not at all obvious. How do we overlap, storage, network, communication, compute together? The end result is to make sure that you get the total training time minimized and do it in an efficient manner to get the best performance per watt, performance per dollar, and then finally get to the accuracy levels that you want, right? So these are all variety of challenges. Next slide, please. Variety of challenges that Huma talked about on the software ecosystem, the software tools, and the whole pipeline and the variety of tools and variety of software frameworks that we need to enable, right, for different hardware targets, and help the ecosystem and the developer, because a lot of them are developing at the top of the stack, but all the optimizations are down the entire stack that we need to be aware of and cognizant of. In addition, we need to be aware of the challenges we talked about on the hardware front, which is things like the really large models. How do you make sure that you partition it and make it multi-node? And there is software challenges, developer ecosystem challenges, tools challenges, hardware challenges, ML ops challenges, and then not to mention the explainability bias, as well as the data drift and model drift and other things that bring another whole plethora of challenges. So every one of these challenges we want to tackle, and we are tackling. If you want to produce good AI software hardware solution, you need to address every one of these. And I will encourage you to go to the AI software homepage. I mean, we touched upon literally at the tip of the iceberg. There is a ton of content and ton of more details, white papers and technical papers and blogs and Medium articles, as well as archive papers, so that you can look at it yourself. And then if you want to dabble into AI, if you're new, you're welcome to look at that. If you're an expert, there's sample codes and things like that that you can look at. And at the end of it, what we want to say is AI can add a lot of productivity to your personal life, and even without a lot of us knowing, but as well as to businesses and enterprises all over the world. But at the end of the day, to produce good AI, productive, explainable, bias-free AI, as well as efficient AI, because we also care about the planet, you need to worry about many, many different aspects of and solve those problems. And there's plenty of interesting problems to solve and work on. So with that, I think I finished on time, maybe 1 minute over. So Huma and I are open for any questions.
Yeah, thank you, Huma and Meena. Really good information, tons to absorb here. I have one question here on the chat window. Sydney, if you're willing to talk, you can unmute and then ask the question, or I can read.
Oh, sure. I was just getting my camera ready. Thank you so much. I was just looking at the ProPublica article, and I saw it was published in 2016 that you're talking about. So I'm hoping we made some progress since then. So I was thinking maybe you could talk about the progress we've made in the last 6 years.
Absolutely.
Thank you so much.
Yeah, that's actually a great question. And I don't know if I said 2016 or not, but it's well known, and it still is one of the most revealing and best articles that was written, because that kind of change, that got people's attention. People have been talking about black box and machine learning is a bit better and this, but until that article was showed, and if I encourage everybody to read how many cases they did, and they showed that people who was most likely to be going back to jail, whereas what the results were, right? So that was a very eye-opening article. Absolutely, things change. Number one, as I mentioned about Cynthia Rutin, she actually worked on this and showed the discussion was around that if you add interpretability into model, they will be less accurate. And what she proved, what her main premise is, that no, you can actually add explainability and interpretability into this, and yet the accuracy will still hold. So her whole research is around that. So number one, to get the equivalent of Nobel Prize in computer science is in this area. This itself shows how much importance is being given to explainability and responsible AI. That's number one. Number two, NeurIPS is one of the, as you know, it's one of the most popular or conferences for AI. And this explainable AI, responsible AI is one of the hottest areas. I will give example from our own side that when we publish something, we have these checks and balances in place, whereas we wouldn't have that until this was exposed and until it was made so clear that this is impacting lives of people. You have an AI model, you just release it, you start using it, but you need to make sure the data is correct, the algorithms are correct, how you're doing. So all of these checks and balances were made because of that. Number four, I can go on and on. I have to stop somewhere, but pretty much all companies you look at, whether it's IBM, whether it's Google, whether it's Meta, they have, you can go there and say, what are they doing in terms of responsible AI? And you will find different things that are happening. So this is a very, very not just legal issue. There are lots and lots of policies in place, but also a technical problem to solve. And again, I'm not saying it's solved, but I'm saying that there are lots of checks and balances in place because of something like this that is happening. And definitely progress has been made. And we have at Stanford, human-centered AI, Fei Li. Then we have Meredith Whitaker in NYU. Many of these people are paying attention to how AI should be used for social good, and specifically make sure that it's not being used for something that can harm people.
So Huma, can I add just one point?
Yeah, go ahead.
Yeah. So this is a very, very hot area, and there's many startups that have come here. In addition to what Huma said about explainability is being very, very important and people are doing it, there is always going to be the human element, right? For example, COVID happened, and as a result in the pandemic, a lot of the demand prediction and supply chain sentiment analysis, a lot of the models kind of broke. That is what is called sort of model drift. We typically think of, when we think of bias, we think of historical bias, right, in the data, but also some life-changing or world-changing event happens, your models might break. So having the explainability and interpretability in the models puts the onus on the person who's deploying to understand, hey, I know why this broke. I mean, COVID was a big one, everybody knew, but suddenly people's buying habits changed. People started buying in bulk, right? And consumer behaviors change. But anyway, so it helps to explain the model.
Yeah, thank you. Naveen, you have raised your hand. Can you go ahead with your question?
Yeah, thank you, both of you. A wonderful presentation. My question is in regards to the applicability of the technology to the business use cases. It appears that we are creating all wonderful technology. AI is wonderful, but in terms of its the ability to use AI, because when we're talking about AI, we're talking about the technology component of it, the quantitative modeling component of it, and the ability to apply it to the business problems. So it appears that we have two types of companies. One type of company like a Stitch Fix, who are really good at making use of AI down to the business processes, which are really, really good at extracting value from it. And there are completely other kinds of companies who have no clue about the technology itself, could be very expensive for them. No understanding of the quantitative models, and much less the ability to take it and apply it to the business processes. And I'm sure that your customers would fall somewhere along the continuum. So my question to you is, what are some solutions that you have found to bring everybody to the platform? Because your topic is AI for everyone and for everywhere, right? So we don't want to leave along some companies along the way. Thank you.
Yeah, sure. So I'll take a stab at it. And in fact, if I don't know if we can get to that slide that I had, all the software stacks and all, if we can, that's fine. If not, I can just talk through it. So, oh, looks like they're doing it. So that, or maybe not, that's fine. So we have, for example, for the second category of people where they need to start from scratch, right? So we have created a tool called AI Toolkit, for example. And that basically has all the different components that you have. That if you want to use TensorFlow, we have optimized solution for that. If you want to use, and we have samples, end-to-end samples, where you will, we would help them. Actually, let me back up a little bit. So we have people who interact as a sales and marketing team, right? First, we will find what their problem is. Because sometimes it's a simple problem. You don't have to have a more complex deep learning model. Maybe it's only machine learning model that would work for them. So first, to finding out what the problem is, the data obviously has to come from them, number two. And then when we find out what the problem is, maybe it's a simple enough problem, we will work with them and help them with the solution. But in general, for many people to just turnkey solution, we have our own AI toolkit. And in that AI toolkit, we will have machine learning model optimized tools. We have deep learning frameworks, etc. In addition to that, we have our own tools, quantization tools and big DL. So depending on what the use case is, we provide solutions. And we have the AI toolkit, you can go and download it and try it, but that's just one aspect of it, right? Then we have trained people in my team. My team also has support. I also have customer support team. So they will actually work with the customers and find out what kind of issues they are having. So we have, it's not one solution fits all. For different kinds of customers, different engagements, we have number one, different types of tools. Number two, we have different engagement models. We have support model. And so it's like a tunnel, right? That we have, that depending on where their solution fits in, we provide assistance to all of those. I know it's a long, winded answer, but in short, to summarize, we have software solutions for all different kinds of problems to solve. We have people who will help identifying the problem and provide solution.
Thank you.
Others, if anybody has questions, please unmute and ask the questions. Otherwise, I can also. Okay, so I have few questions here as well from an audience. So question for you, Huma, and I know you're very much passionate about helping women in this area of the AI and big data field. How do you support women entering the field? There are some students in this call as well.
Oh, okay, sure. So yeah, that's been something my entire career I have been very passionate about, women, STEM, women education, and for the past few years in AI. So number one, I do personally mentor a lot of young women, even high schoolers, and I founded, I think Geeta is here as well from our TensorFlow team. So I've founded Women in Machine Learning at Intel. And then, of course, go to work with Girls Who Code, Girls Greek, and there's a foundation called Led By, where I mentor people. But that's orthogonal to what the discussion is. So in general, in order to attract women, we have to show girls and young women how AI is relevant to the world and how they can be part of the exciting and impactful solutions. So, if they're looking at exciting solutions, applications like Alexa or self-driving car, or watching net recommendation on what movie to watch, they will see that this is something that is impacting their work, versus when we used to do software engineering, sitting in a cube doing work, it was not so much evident that how exciting that can be. So that is number one, that you show that you're working in AI, which is really having a huge impact. Number two, as I mentioned earlier, that a key part of attracting women is representation. And fortunately, I see more and more women in AI who can serve as excellent models. I talked about Fei-Fei Li from Stanford, Meredith Whitaker, and many people here and from my team. We have Meena, we have Geeta, who is from the TensorFlow team, and many women here. We mentor many people, and we do that. So striving to be a role model is another thing. And my last point would be that AI is an extremely interdisciplinary field. So you can apply AI to almost any domain that you're involved with. And these days, the frameworks and tools, and even our tools we are striving to have no code or low code, right? Very easy to use. And that can also answer Naveen's question, that make it so easy that you download and maybe one line of change or no line of change, you can start using it. And so there's so many options there, right? If somebody who's starting new, there are courses in Udacity, and you have so many other places that you can, Coursera, you can start off from there. So resources are available, open, online. You have lots of mentors. And so it's getting easier and easier, and we are all doing our part.
Yeah, great. Thank you. And with that, we are going to conclude today's event. First of all, I want to thank you, Huma and Meena, for making your time to come and then give the insights into all the great subjects that you are exploring and investigating. And also all the people who joined the call today, thank you for your time. And the committee, the Women in Big Data Northwest Committee, we worked very hard to put this piece together. Thank you all, the committee members. With that, hope you all will have a wonderful evening, and we will continue to bring these kinds of events to you. And please stay tuned. Thank you.
Thank you, Surekha and the committee for the opportunity, and all the very best under your new leadership.
Okay, thank you. Take care, everyone. Have a good night.
Yeah.
Bye.
Bye.
Thank you.
Thank you, everybody. Bye.
Thank you, everybody.